Hi guys, welcome to another video on the Eagletree vector. Now this is actually going to be an update video, and chances are if you're looking at this video you would have found it one of two ways. Number one, you may be a loyal subscriber to my channel, in which case thank you very much for subscribing and hopefully this will come in of use to you. The other way is you may have clicked on one of the annotated links in some of the original videos I did. Basically, since actually doing those videos, which were all off my own back after receiving the vector, and they were all based around me literally setting it up for first time flight with it. After that, they obviously got a fair few views, and actually Eagletree themselves saw these videos, and John from Eagletree was very kind to get in touch with me and agreed to have a bit of a Skype chat with me to put a few facts straight that I was questioning in the videos, and also to just clarify a few points. So after about 45 minutes on Skype with him, he's managed to cover a lot of the options, and that's what I'm going to talk about in this video. Now this will cover both multi-rotor and it will also cover fixed wing, so I'll just go through the various settings which I've mentioned, which probably need a bit more either clarification or were basically wrong when I said it. So we'll start with the first one now. Okay, so the first point that I'm going to clarify is actually about flaps. When I talked about the setup in my original video for fixed wing, I actually said that you would configure your flap switch, and that's how you're actually going to be using the flaps. Now, basically, with a bit of clarification from Eagletree, the flap switch itself is only actually used if you're using an airframe that uses flapper-on mixing. If you're using a standard traditional fixed wing aircraft like a Bixler with flaps or something like that, you would plug your flaps into the RX directly, so you would actually run an auxiliary channel to the flaps as you would any other standard way, and then you can actually control the servo directly. The only reason that there's the flaps output for the vector is so it can actually do and handle those flapper-on mixing whilst using an airframe that requires it. So if you're using a wing, for example, which requires flapper-ons, then that's where you can actually add some flaps, but also as part of the stabilization, the vector can manage those flaps in sort of unison with the aileron part of the flapper-ons. So that's just to clarify. So again, if you've got a standard fixed wing, all you need to do is just find an auxiliary port for your receiver, plug it into that, and then just work it manually from a channel on your receiver. Sticking with fixed wing, the next thing that I'm going to mention is actually the magnetic compass. Now, a couple of people pointed this out on comments on the videos, and again, this is something that's been clarified by John at Eagletree. Basically, from the point of view of fixed wing aircraft, the magnetic compass is not needed. It's not just a case of it's not needed, it's actually advised, when I had a chat with him, that you don't use the magnetic compass when flying fixed wing. Now the reason for that, which makes perfect sense when it was explained to me, is that when you're flying in fixed wing, your compass is basically dictating which way the aircraft is pointing. So if you've got the magnetic compass enabled, then north is a certain way. However, the problem that you've got is that with a fixed wing aircraft, there is things like wind shear. There's elements that are pushing your aircraft to one side. So if you're crabbing along in a certain way, then actually your aircraft could be flying north when actually your compass is pointing in a completely opposite direction. So it could be basically pointing northeast. So the advice from Eagletree on this point is for fixed wing, basically is best not to use the magnetic compass. Still in the compass and sensor setup, the next thing I wanted to talk about is the GPS fixed quality settings. Now, I mentioned in the original setup videos that the vector wouldn't actually allow arming unless these prerequisite defaults were actually met. That is in fact not true. You can arm the aircraft, you can fly the aircraft. The only thing that will happen if you don't actually have, say, if you've got 5 satellites or if you've got a very high H-stop reading, if that is the case, then basically it just won't allow you to go into GPS fixed mode. Now, from the point of view of, say, a multi-rotor, that means you will not be able to go into loiter, polar loiter or Cartesian loiter. From the point of view of an aircraft, obviously that's going to mean that you're not going to be able to do any of the return to home features. That is also of course true from the point of view of a multi-rotor as well. So again, it's not a case of you're not going to be able to fly the aircraft or take it off or anything like that. It's just going to simply be a case of when you get in the air, you're not going to have any of your GPS abilities until you've actually got a firm fix from the GPS. Now, the one thing that's always good with that is because the OSD is very good on the Vector, what you'll see is you'll get a warning saying cannot use GPS. It's basically telling you that you cannot and should not use any of the GPS modes because the calibration has not been successfully fulfilled to the minimum of the GPS standards. The next thing to mention is actually for multi-rotors more so than fixed-wing aircraft, and that is in fact the kill switch. The kill switch, basically, which is set up, is designed to prevent arming of the motors until you actually have the kill switch activated. Now, I mentioned in my original setup video that if you are using a multi-rotor and you flick the kill switch, that's it, your motors will turn off in the air. Now, Eagletree confirmed that that is actually the case. The motors will turn off. However, provided you are actually quick enough, you can reactivate the motors as long as you say flick it back on within a couple of seconds, usually about a second is what we believe. Now, the reason I'm saying this is because it's been mentioned in the video. However, as I mentioned in my multi-rotor setup video, it's not something that you want to test. It's not something that I'm going to be testing myself. The key is really to make sure that you have a switch for your kill switch which is nice and out of the way from your fingers. One suggestion that I made in the multi-rotor setup is potentially if you have a potentiometer or you have a spare potentiometer, so for example I use a Futaba T14 SG, there's plenty of sliders and dials that can be used, and what you could actually do is you could configure your kill switch to be on one of those, which means you've got to actually physically turn a knob to turn your motors onto an armed state, and you've got to turn it all the way back to actually kill them. That way there's no risk of you accidentally flicking something and then killing your motors in mid-flight. The final element of this update video is actually just discuss the modes. My more recent multi-rotor setup video does have all the modes, and that video was actually made after the conversation that I've had with Eagletree. So I clarify what each mode does in a bit more detail. I was a little bit vague when I talked about it in the original video, and obviously that was because I was looking at it more for the fixed wing point of view. What I would do is advise that you look in the comments below this video. It will point you to the other videos in the series. The multi-rotor setup video especially, what I've done is I've actually put some specific timed points for when each mode is talked about, what it does, and basically, you know, the advantages, the disadvantages, and things to look out from that point of view. The only other thing that I would mention from the side of actually multi-rotors, and again it is in the multi-rotor setup video, is that it was advised that when taking off it's probably best not to use a mode that has an altitude hold, because the aircraft can actually sort of leap up in the air and then immediately go into a kind of a state where it's looking for a specific altitude at 50% throttle. It's something that, again, it's not going to cause you major chaos, but I would say from the advice that was given, it's probably best that when you take off in a multi-rotor that you leave it in 2D no hold, just to get it in the air, and then of course after that, as long as you've got a GPS fix, you can throw it into loiter. If you've got if you've got no problems with it at all, you can put it into a hold after that, or any of the other modes. Again, there's a section in the multi-rotor setup video that covers that in a bit more detail, and I actually talk about the preferred setup from my own preferences as a pilot. You know, when you go to the field, what you kind of want to have for each of your modes and your sub modes in an ideal scenario to give you kind of the best layout potential if you've got 2-3 pole switches. So check out that video anyway. Hopefully this has been of help. Obviously, if this update doesn't cover anything, if there's something that you would like to be discussed further, if there's questions that you've got, please feel free to put a comment on there. I'll try my best to try and get a reply to you as soon as I possibly can, even over Christmas. But anyway, hopefully that will set things straight a little bit, and I hope you enjoy flying the Vector.